Good afternoon, everybody. Thank you very much for coming to this conference, and thanks for the organizers to give me the chance to give you like a brief presentation about my last research. I work at Jordan University of Science and Technology for a year so far. Today I'm going to give you like a brief presentation about my last research in Wales. It was a part of my PhD. It's about using a computer-based technique. It's a novel technique for building dental and removable orthodontic appliances. This technique is called 3D printing or additive manufacturing, or we call it like CAD-AM. All these words refer to one technology. It's very much similar to CAD-CAM, which is computer-aided design, computer-aided manufacturing, which is very common these days. But there is like a few differences between CAD-CAM and CAD-AM. So my focus in this presentation on CAD-AM, it's this technique is it appeared recently after the presence of CAD-CAM. Both CAD-CAM and CAD-AM consist of three components. First of all, digitization, which is taking a scan either for the patient's mouth using intraoral scanner or by handheld scanner, which is like extraoral scanner. Both of them should take like three-dimensional image of the patient's mouth or the dental cast. The second component is called designing, which is using the computer software to design the appliance that should fit on the image taken by the scanners and appears on the screen. The third component is called manufacturing. It's a machine that produces the appliance according to the software design. We should, as you see in the picture, the last one, you can see the computer. So this machine works with the computer. And there is a difference in the machines between CAD-CAM and CAD-AM. So that's the difference in the third component. This slide shows you like different machines for 3D printing. There are many in the market, honestly. There are different costs. They produce different materials. They produce different accuracy. For example, this is like stereolithography is one of them. This machine is very good because it produces objects from plastic. Polyjet machine is another machine as well. Like the one who experienced in CAD-AM in these machines, he knows the difference exactly. For example, stereolithography, once you turn it on, you can stop it. You can pause it at any time, and then maybe you can continue your work the day after. But with Polyjet, once you've turned it on, you can't stop it. So this thing, it's related to the appliance that you want to build, and I will talk about that later in this presentation. So the CAD-AM, it's very common in industry, honestly. It's in industry, and now it's been introduced to dentistry. It's been used very common in maxillofacial prosthesis for building like noses, ears. The difference between CAD-AM, this technique, and the CAD-CAM is called milling. CAD-AM is called 3D printing. This technique can produce any design with cavities, with sinuses, with any irregularity. But the milling cannot produce these sinuses and cavities, so that's the difference. And it's been produced also in the removable partial denture. As we all know, the removable partial denture have like straps, have clasps. It's very like tiny, small parts. And it's been produced as well in lingual orthodontics from gold. So as you can see, it's been spread in all fields in dentistry. For example, maxillofacial, it can produce it from a plastic or from wax. For RBD, from metal. For lingual orthodontics, from gold as well. So different materials as well. In this research, honestly, I've used freeform modeling plus version 11. It's a software, it's a freeform, it's not a dental version. That was the facilities of the challenge of using this software to produce the appliances that I will talk about in the next slide. This software works with three-dimensional mouse. Which called a phantom arm. With this design, with this software, it was a challenge for me, like to develop this free-form software to produce dental appliances. So from the tools that it's in the software, I could identify the undercut of the cast. As you can see here, the undercut shows in blue color. And you can also select the correct path of insertion. It depends on the appliance that you want to design. As well, I could with this software block out the undercuts automatically by just one click. So that was very easy. Honestly, it's easier than making that with hands. The objectives of the research was to explore the possibility of building the following devices from intraoral scan using additive manufacturing technology. The appliances that I tried to produce and developed in this study were inclined blocks of a Newport style twin blocks. The second one was sleep apnea appliance, incorporated 4 rotating hinges, all in one build, all in one piece. And the third one was building alloy components and inserting them in a retainer. It's like Adam's glass and metal, and inserting them in a retainer of plastic. The methodological approach to undertake a series of case studies, which each device forms the basis of a single case study. Of course, it's a developing study. So whenever I've tried to build a sleep apnea device, for example, it didn't happen from one click. It took months, weeks, and maybe one of them years, So that's why it's a series. So, and the first one I've produced, I called version 1. The second one, if it's better, I called it version 2. And so far, till I got the final one, the most successful one, and I called the successful version. There was a parallel study talking about the same idea, but it was concentrated on RPD. The studies it started on dental cast. They scanned a dental cast, not the patient mouth. So they scanned the dental cast, and they used general version of a free form, and then they produce this RPD from a plastic pattern, and we all know that we need cobalt chromium, so they had to flask it, deflask it, and investing and all this process till they get the metal. So that was a long process, and a lot of problems appeared as well. Then they moved, when their process was great, to use intraoral scanner instead of taking the impression, so we can decrease the steps of taking impression and the problems associated with that and the disinfections as well. So I hoped in this research developed here can follow a similar path in the future. So that's what but I used it to develop orthodontic appliances instead of RPD. So I started with dental cast with general form to produce a plastic pattern of orthodontic appliances, and later to produce orthodontic appliances from metal, such as clasps. And now I'm working on using intraoral scanner as well. How to achieve the objectives? Yes, general version of a freeform and dental cast as a beginning. The first one I've developed, it's called a sleep apnea device. As you can see, this is the virtual version. When I say virtual version, it means the design that appears on the screen. So it consists of upper blade fit on the upper jaw and upper teeth, like buccally, lingually, the same on the lower, and they are both connected with bars from both sides. You can see here, this is like a bar, and they are called hinges. So on each side, there are two hinges connected with one bar. In this image, you can see like two different colors, but actually they are one material in the screen, but I've changed the colors to be clearer to you. So the idea here, I had to make like a gap between, like the blue color and the yellow color, like 0.5 millimeter. And again, there is like a gap between, like internally and from the side. So there was a gap here, and a gap here, and a gap from the inside as well, to enable the hinges to move, to rotate. And in this way, it can move the lower forward. And that's why we can treat the sleep apnea patients or the snorers. Is that clear? Anyone has a question? Yeah, here. Yep. So, and that's how it appeared. And then when the design was ready, I sent it to the machine, and it's built from a plastic, and that's how it fits on the jaws. So it wasn't like easy, like to find the correct, the space, how much it should be. It wasn't easy. Like I've made so many, honestly. Some of them were broken because the gap was not enough. Some of them, the hinges were not very strong. They were not very thick. That's why they're broken very easily. So I had to make so many till I get these dimensions. The second one, because most of the orthodontic appliances consist either from metal or plastic, so I've tried to build like a retainer like a base plate and Jackson clasp on the incisors, plus like a C-clasp on the molars. And it was possible. Like the way of doing that, I drew the clasps on the cast straight away. And as you can see here on the cast, they look like pink, because with this software, I could make the cast as a buck. Buck means like I can't make any deformation. I can't make any changes. If I click on if I want to scratch it, nothing happened. So it means it's protected. So, and that was very good. So this means if I want to trim or to delete these lines, it will not change anything on the dental cast itself. So it's protected from scratches as well. So I drew the Jackson clasps on the insides are the same on the molars, and I connected them with a base plate. That's how it looks on the virtual image, and then I built it from a plastic. They were successful, but not 100%, because the clasps were plastic and the connections between the clasps and the piece were very weak, so it was easily to be broken, honestly. And the other way, I tried to make to thicken the area here, but it was bulky and uncomfortable to the patients as well. So I tried to think in another way. What about building the clasps from metal and connected these with base plate as it is close to the actual retainer. So I've tried to, now I'll try to build labial fitted bow and Adams from metal and insert them in a base plate, and that was very difficult because they are two different materials. They are very much different from the previous two appliances, and the problem as well, the Adams class doesn't it fit on the tooth itself. There is a gap between them, so I had to build like guiding jigs before constructing the Adams class. So I had to make the guiding jigs here in certain dimensions in a way like the Adams should fit 100%, because drawing should fit in, should contact a surface. So I cannot like draw without a surface. So I had to build these guiding jigs and then remove them later, you know, just like for building the appliance. So yeah, and yeah, that's how the Adams clasps and the labial fitted bow looked like. And I had to build, you know, the Adams and the labial bow, or I should insert them in the base plate all at once, because it's a layering that the additive manufacturing technique is called additive or layering. So all the appliances should be built layer by layer, and they should be there should not be like they should be on the same plane. So I had like to start building. I had to start building the base plate. Can you see here the plane? From here till I get to this plane, then I paused the machine, the polyjet machine, then I inserted the appliances, and then I inserted the Adams clasp and the labial fitted bow, and then or turn on the machines again till I get to the final. So I couldn't like build them together. I should start with base plate, pause the machine, start again till I get this form. And the last one, I think, or maybe the one before the last, it's called a Newport 20 block. It's myofunctional appliances, as we all know. It uses to forward the mandible. So I tried to, there is like a Newport style 20 block. It's related to Newport area in United Kingdom. It's about like a base plate on the upper, base plate on the lower, and there are like blocks, one block anteriorly fit on the lower without Adams, without any metal components. So yeah, I used this design to build it using additive manufacturing and using the freeform software as well. And everything was successful, honestly, with that one. And I tried it in a patient mouth, and that was great. The fitting was okay. The issue that solved with this technique that I didn't have to finish or polish of the plastic, so it saved time, and it no need to use like bears, no need to, you know, like to keep you busy like with finishing and all these steps, and the fitting was great. Yes, and again, like the last one I've developed in this study as well, Andresen. We all know like Andresen, it consists of plastic, or maybe like acrylic, connected the upper with the lower with a labial bow. And it's been developed in this study as well. I thought it's gonna be very easy. I could only like build the virtual Andresen and make holes here to insert the labial bow, but that was wrong, because the holes were blocked, because they were very tiny and it wasn't easy to insert the labial bow. So I had to think another way. I had to build like guiding jigs for the labial bow. If they fit on the guiding jigs, it means they will 100% fit in the whole appliance. So I had to build the virtual, the whole, and at the same time the guiding jigs. And then when I say like build it virtually, then I had to build this physically until I get it like this with plastic. Then I made the labial bow and it fit okay, then I build this with labial, with the machines, like, again, start the machine, then pause it till this level, till I can insert the labial bow, then restart the machine again. That's the final and race and how it looks. So with these techniques, okay, we can like skip the step of taking the impression, putting the impression, transfer the impression, you know, the problems with the alginate, the problems of not putting the cast on the impression on time, the miscommunication between dentists and dental technicians, all these problems are avoided with using the digital casts. So again, these are the steps, version 1, version 2, version. These are all the difficulties I've encountered, honestly, to produce the Andresen. I had to produce like 5 till I get the last or the most successful one. The potential benefits of this technique, a successful application of additive manufacturing in building dental devices from different materials, which is good. Like with this technique, we can use we can produce dental appliances from different materials, as you've seen here, like acrylic or plastic. We've used like metal. Sometimes with these machines, we can produce it from wax, and then we can, like in maxillofacial, and then we can transfer it to acrylic or to silicone or to whatever. No need of great skills and experience, like with using the software. There's no need for experience for the dental technicians. It's just like you can drag and it's like any software, it's easily. No need for physical room to keep the dental casts. And it's a very good point, I think. And you can just save the virtual scan of a dental of patients in the computer, and you can go through it at any time, and you can save it. It doesn't take any space, and it's protected from scratches or lost or anything. You can, and dental casts are protected from damaging during building as well. As you've seen here, it's when we convert the dental cast to buck form, it means it's protected. If you need to make any changes, it doesn't affect it. Also, sometimes like when you make like a buck, you may like undercut, block on the undercut, then you can transfer it all into the buck. This means the blocked out undercuts casts are protected. And that's the end. Thanks for listening, and I'm happy to answer any question if you cross in your mind.
Thank you, Professor. Let's give a thanks. Perhaps there are one or two questions that people would like to pose. Questions? Ms. Lieberman.
I worked on a study where we were scanning and comparing digital dentures to traditional dentures. And when we were putting the powder on and using the scanner, we had issues in the maxillary vestibule. Have you had any issues with that while you're scanning for your retainers?
Why I'm scanning?
Adapting the wand up into the vestibule.
What I needed from scanning, do you mean?
Okay.
Can you say the question in another form?
When you're scanning the maxilla,
yeah,
and you're working in the vestibule,
yeah,
do you have any issues with the size of the scanner to get all the height of the vestibule and all of the frenum?
Yeah, I think there are different types of intraoral scanner. I think you asked about intraoral scanner. I've used one of the best, maybe intraoral it refers to 3. It wasn't like very easy to catch all maybe the posterior areas, but I think with experience I get it much easier and better, honestly. It didn't have to like maybe spray powder or something like. Other intraoral scanners, you should separate like a powder before you scan, and that's uncomfortable to the patients and as well to the clinicians, so he cannot maybe like recognize which areas were scanned or which is not. So with the intraoral scanner that I've used, it was easy, honestly. It was hard maybe for the first and the second time, and then everything was okay. So with experience and training with the trainer, I think it will be okay.